Good day everyone, finally we have reached our last topic before the semester ends, and in this video we will be exploring chapter 7, namely applications of integration. This topic will be divided into two subtopics. In the first subtopic 7.1, and in this video you will learn to determine the area of a region. And in the subtopic 7.2 later on, you will explore how to determine the volume of a solid revolution. Does it sound interesting to you? Okay, so without wasting much time, let us proceed. In determining the area of a region, one has to be able to understand and solve these three cases. The three cases are area of a region bounded by the curve and the x-axis, bounded by the curve and the x-axis, area of a region bounded by the curve and the y-axis, and finally area of a region between two curves. When solving, you must always remember to use the correct formula, which I'll be guiding you later on, and you have to note that the area you calculate has to be bounded by the conditions. And most important thing, area has to always be positive. And so in other words, your answer has to be always positive. Don't you worry, for as long you stay focused in this series of videos, you'll find them easy to solve. Now we are going to focus in our first case, which is area of a region bounded by the curve and the x-axis. If f and g are continuous with fx greater or equals to gx throughout the interval a and b, then the area of the region between two functions y1 equals fx and y2 equals gx from x is equals to a to x is equals to b is the integral of ab fx minus gx. Okay, so this is your first formula. So how does that means graphically? Okay, so let's say you have two functions, fx and also gx. So fx is greater than gx, that's why fx is on top of gx. Okay, it is greater or equals to gx. And so we say that we want to integrate from x is equals to a and also x is equals to b. Okay, let's say x is equals to a is somewhere over here. Okay, we label it x is equals to a and x is equals to b is somewhere right here. Okay, the area that we want to find actually is the area in between them. So this area that I've shaded right here is the desired area which we want to find. Okay, so how do we go about finding it? So this is when we would need this formula. This formula right here will be useful for us. So we integrate from a to b, okay, then we take fx minus gx. So that is how we get the formula right here. Okay, so if you were to look at the formula closely, you can actually rewrite it into area is equals to a to b, and you can write it y1 minus y2 integrate it with respect to x. So how does it becomes like this? It is because that we have already said earlier that y1 is equals to fx and y2 is equals to gx. y2 is equals to gx. Then what we have done just now is we just substitute fx with y1 and gx with y2, and so we'll get another formula. Okay, so these two formulas are the same. Okay, they look different but they are actually the same. We just substitute fx with y1 and gx with y2. So as a rule of thumb, to find the area of a region bounded by the curve and the x-axis, it will be a lot easier if you remember the formula this way. So you take the integral bounded from a to b, and you take the upper function minus it with the lower function, and you integrate the whole thing with respect to vx. So this is how you remember the formula. So in our case right here, you take the upper function, which is fx, and you minus it with gx, which is the lower function. When we have such graphs, and if we were to ask to find the area between the interval a and b, and also the curve y equals fx. So how do we go about finding it? So the area that we want to find is actually the area that I am shading right now. So this is the area bounded by the curve and also the x-axis. So what we have just said just now is we take the interval a, b, and we take the upper function minus the lower function. So our upper function in this case is f of x, and our lower function is the x-axis. So y is equals to 0. So we'll get 0. Then we will be integrating the whole thing with respect to x. So this is how you get the formula ab fx dx. Now, if we get a function which is located below the x-axis, and if we were to find the area bounded by the curve and also the x-axis in the interval a and b, so let's say this is our a and this is our b. So the desired area that we want to find is the one that I'm shading. So how do we find the area? So what you need to do is you still use the same formula, which is you take the upper function minus the lower function. So in this case we are in the interval of a and b, and so we take the upper function. So now our upper function is y equals 0 because we are on the x-axis, so we'll have 0 minus the lower function. So our lower function is y equals gx. So this will be gx. The whole thing, the whole function, we integrate with respect to x, so we put dx. And so what we'll get from here is integral from a to b minus gx dx. Or we could also write it down. It becomes integral from a to b gx dx. So that is how you remember the formula to find the area of a region bounded by the curve and the x-axis. So we have three different forms of formulas right here, but they are actually similar. So you can use either one of them in finding the area of region bounded by the curve and the x-axis.